Hello everyone. Now I will discuss the question number 11. An ideal gas of density rho is 0.2 kg per meter cube enters a chimney of height h at the rate alpha is equal to 0.8 kg per second from its lower end and escapes through the upper end as shown in figure. The cross-sectional area of the lower end is A1 is equal to 0.1 meter square and the upper end is A2 is 0.4 meter square. The pressure and the temperature at the lower end are 600 Pascal, 300 Kelvin respectively, while its temperature at the upper end is 150 Kelvin. The chimney is heat insulated so that the gas undergoes adiabatic expansion. Take G is equal to 10 meter per second square, and the ratio of specific heats of the gas gamma is equal to 2. Ignore the atmospheric pressure. So you have to calculate the pressure of the gas at the upper end and density at the upper end and speeds at lower end and upper end, what are the values, and density also you have to calculate. Height of the chimney also you need to calculate, given that gamma is equal to adiabatic constant is given 2. Now you can see that according to the question, it is adiabatic process. Whenever adiabatic process is given, you know that PV power gamma is equal to constant. PV power gamma is constant, or we can write it as PV is equal to nRT. So I can write T divided by the P whole to the power of gamma is a constant. You can write this as P1 power P power 1 minus gamma into T power gamma is constant. You apply the pressure and temperature relations at bottommost point and topmost point. We can write this as P1 divided by the P2 whole to the power of 1 minus gamma is equal to the T2 divided by the T1 whole to the power of gamma. P1 value is 600, P2 value you don't know, 1 minus gamma value is 2 is equal to T2 value is 150, T1 value is 300, whole power gamma is 2. So you can see this will be 2 times get cancelled, and again you can write the value as 600 by P2 whole to the power of minus 1 is equal to 1 by 4. So this can be written as P2 by 600 is equal to 1 by 4, or we can write the P2 value is 600 divided by the 4. We will get the 150 Pascal. P2 value is 150 Pascal. They have given 300 Pascal, which is a wrong option. Again you can check that density of the gas. Fourth option I will check now. The density relations, we can see that P by rho is equal to RT by M. P by rho, this is rho is density. Now we can write the rho is equal to M P divided by RT. M and R are constants, molar mass and gas constant is constant. We can write rho is proportional to P by T. If we write the rho is proportional to P by T, rho 1 divided by rho 2 is equal to P1 by P1 by T1, P1 by T1 into you can write the T2 divided by the P2. So rho 1 value is given according to the question. Rho 1 value is given 0.2. So substitute there 0.2 divided by the rho 2 is equal to P1 is 600, T1 value is 300, T1 value is 300, T2 value is 150, P2 value is 150. So if you see that this one get cancelled, 2 times get cancelled, rho 2 value is 0.2 divided by the 2, we will get the 0.1 kg per meter cube. So rho 2 value is this. We can see density of the gas at the upper end is given 0.05, which is wrong. Now we will see for other terms like velocity of the gas at the lower end is 40, upper end is 20 meter per second. Further they have given mass rate is given 0.8. You know that according to the continuity equation, dm by dt is constant. That value is rho 1 a1 v1 is equal to rho 2 a2 v2. This dm by dt value is given 0.8. Now substitute one by one. First a1 is 0.1, a2 is 0.4 is given, and just substitute the rho 1 value also there 0.2. Rho 1 value is 0.2, a1 value is, you know that a1 value is 0.1, v1 is equal to 0.8. So if we substitute that, we can get the v1 is equal to 0.8 divided by 0.2 into 0.1. We'll get 40 meter per second. Similarly, rho 2 A2 V2 is equal to 0.8. Already rho 2 value got 0.1, A2 value is 0.4, V2 into 0.8. So from this we can get V2 value is 0.8 by 0.1 into 0.4, we get 20 meter per second. So according to this we can see that this is 40 meter per second, this 20 meter per second. Option B is correct. Now we are going to check for the height of the chimney is how much. So for this height of the chimney we can see that the gas is doing work done by gas is equal to, it is changing the kinetic energy, changing the potential energy, and changing the internal energy also. Change in internal energy of the gas, internal energy of gas. Here gas is expanding adiabatically. Work done by the gas can be written as P1 into delta V1 minus P2 into delta V2, that is the pressure at bottommost point work done to the topmost net work done I have written. Delta K is off into delta M into V2 square minus V1 square, and potential energy is delta M into GH, plus this value can be written as F by 2 into, it is adiabatic process, only internal energy change is P, you can write it as P2 into delta V2 minus P1 into delta V1 you can write. So if you observe these values, F value is how much, gamma is equal to 2 is given, so CV you can write it as CV is equal to R divided by the gamma minus, you can write R by 2 minus 1 is R only, and F is equal to CV is equal to F by 2 into R. CV is equal to F by 2 into R. We can write that F is equal to, will get 2 only, substitute there. We can write the P1 into delta V1 minus P2 into delta V2 is equal to half into delta M into V2 square minus V1 square plus delta M into GH, plus we can write F is 2. If we substitute the F is equal to 2 here, we can get again P2 into delta V2 minus P1 into delta V1. So we can write this value is 2P1 delta V1 minus 2P2 into delta V2 is equal to half into delta M into V2 square minus V1 square plus delta M into GH you can write. I think outside some festival is going on. So you can write the value is 2 into P1 delta V1 by delta M, delta V1 by delta M minus 2P2 into delta V2 by delta M is equal to half into V2 square minus V1 square plus you can write it as delta M is already cancelled, you can write the G into H. Now substitute the values. 2P1, this value is rho 1 minus 2P2 divided by the rho 2 is half into V2 square minus V1 square plus G into H. 2P1 value 2 into 600 divided by the rho 1 value. If you see rho 1 value is 0.2 minus 2 into P2 value is 150 divided by the 0.1 is equal to half into V2 square. V2 square is equal to 420 square, V1 square is 40 square, 1600 plus G is 10 into H. So if you substitute the values of this, we can get the 2 get cancelled, 6000 minus here also 1500 and this 3000, that value is half into minus, this is you can write it as 1200 plus 10 into H. If we substitute these values, we can get the 3600 is equal to 10 into H. H is equal to 360 meters. So according to question, they have given that 590 meters. It is wrong. So according to options, we can see only option B is correct. Option B is correct. If you neglect the internal energy, now that time you will get the 590 meters. Okay. If you neglect the internal energy, you will get the 590. If you consider the internal energy, you will get the